Alright, so for number 3, this is a review of a constant of proportionality. This is something we did a while back where we were drawing the arrows from one column to another to compare the cost to bagels, for example. So we want to know which equation we can use to represent the cost for 13 bagels. So if we look at this problem, we can see that as the number of bagels increases, this increases by a constant amount. That's what makes this proportional. So when we're multiplying and increasing, how much are we having to multiply when we're going this way is the question. So we know that each time that we're multiplying, we know that we went for every one bagel is 75 cents. And then when this doubled, this also doubled. Or in other words, we're adding 75 cents each time. So whatever this number is, we see that we just multiply it by 0.75 and then we get this number right here. So our constant of proportionality is 0.75. Each time we're multiplying, multiply this number by 0.75 and you get this answer. You can see every time you can check on your calculator. Each time you'd multiply by 0.75, you'd get this answer. So if our number of bagels is B, we want to multiply times 0.75 in order to get the cost, which is C. So now we want to look for something that looks like this. So it wouldn't be quite in this order, but this is just how we figured it out, talking it out as on the video. So we know it can't be this one because that is saying that B equals something. And we know that it needs to be just 0.75 times something. So it can't be that one, and it can't be that one. So we know that it's got to be this one then. Because every time the bagel amount goes up, the cost of the bagels goes up exactly the same amount each time by 75 cents. That's how you do number 3. Last one is number 4. So this is again talking about the constant of proportionality. This is just testing your knowledge of being able to read a graph. So we want to know which statement best fits the graph. So if you look at this graph, you can see that as the number of seed packets increases, the number of flowers also increases because the arrow is going this way. So if you look at the numbers that they give you, we have 1, 4, and then we have 2, 9. So I'm going to write these down so we can see them. 1, 4, and then 2, 9. So if you read it in order, so we see that one seed packet will then produce 4 flowers. You have 2 seed packets, I'm sorry, that's a 8, not a 9, will produce 8 flowers. So let's look and find one that matches this. So we see that the constant of proportionality is 1 because one seed packet produces 4 flowers. Well, this is true, but it doesn't look like it's just going up by 1 each time. So let's look at it and see that the constant of proportionality is 4. This means one seed packet will produce 4 flowers. So far these might be okay. So they all are starting to look similar, so what we need to do is set up a chart like we did before. So we have 1 flower, 1 seed produces 4 flowers, 2 seeds produces 8 flowers. So again, what are we multiplying by each time? Well, you can see that we're multiplying by 4. We're doing the arrow thing just like we did in the previous problem. So then if we had 3 multiplied by 4, it would produce 12 flowers. So that if this is seeds and this is flowers, every time you have 1 seed, you multiply by 4 to get to the new one. And that's why it makes that straight line. So the only one that has that constant proportionality of 4 is B. So make sure you do number 2 on your own, and then you are done.